When determining a limiting reactant, one of the methods you can use is the reactant stoichiometry method. If this method makes sense to you, then go ahead and use it. If it doesn't, give the theoretical yield method a try in the other video I put up today. To use the reactant stoichiometry method, you're first going to need a balanced chemical equation for the reaction in question. Second, you will calculate the moles of each reactant from the masses given in the problem and the formula weights of those reactants. And then the third thing you'll do is compare the ratio of the given moles to the ratio of the moles in the equation. Over here I've got my equation moles of A over moles of B, and here I have my given moles of A over moles of B. Now it's important that you just keep whatever is on top consistently. It doesn't matter, what A and B actually are. If the equation ratio is greater than the given ratio, this means that A is your limiting reagent because there's less proportionately A in the given situation, meaning that A is the limiting reagent. If, on the other hand, the equation ratio is less than the given ratio, this means that there's an abundance of A, and therefore B is the limiting reagent. Now let's see this in action. Now we will use the reactant stoichiometry method to determine the limiting reagent if we have 3.33 grams of calcium chloride that we're trying to react with 6.12 grams of potassium phosphate. I have my balanced equation here. You can check out the other video I put up today if you want to find out how I got it. And I've got the molecular weights of 3 compounds mentioned in this equation. To use the stoichiometric reactant method, you're going to start by calculating the moles of each of your reactants. So first, we're going to do 3.33 grams of CaCl2. We know that 110.98 grams of CaCl2 goes into 1 mole of CaCl2, which means that we currently have 0.0300 moles of calcium chloride. We can do a similar calculation for the potassium phosphate. 6.12 grams of potassium phosphate and 212.27 grams of potassium phosphate goes into 1 mole of potassium phosphate. Crunch those, we get 0.0288 moles of potassium phosphate. Next, our second step is to construct our ratios. So on one side, we're going to take the ones from the equation. So in our equation, it is 2 moles of potassium phosphate over 3 moles of calcium chloride. And you could put either one of them on top, just so long as you're consistent. It's going to be versus what was given to us. In this case, we've got the 0.0288 moles of potassium phosphate over the 0.0300 moles of the calcium chloride. Now we're going to calculate, just crunch those down into digits so that we get 0.66 equation versus 0.96 given. Now, since the given is larger than the equation ratio, that tells us that whatever is on the bottom of the given is the limiting reagent. So this tells us that CaCl2 is limiting.